Okay guys, well now that we've done a little bit of the theory behind binomial expansion, we're going to work on some practice. And you've got this big formula here, x plus y to the power of n is equal to n choose 0 times x to the power of n, y to the power of 0 plus n choose 1, etc. up to all the way up to n choose n. Now this formula is a little bit hard to understand, so I thought I might whip straight into an example and this might help you understand how it works. So let's have a look at this. We've got 3 plus x to the power of 8 and we've got to find the first 4 terms of the expansion. Right, well, first of all, our n value here is 8. So we're going to go 8, choose 0. Now, as we discussed in the last video, that means that we're going to have 0 x's, right? This is our x to the power of 0 term, but at the same time, our first term is going to be 3 to the power of 8. So you can see that that fits what we've got here. Our second term is to the power of 0, and our first term is to the power of n. Okay, that's how we start these off. And you can imagine, look, I mean, I can go into a little bit more detail if you want. 3 plus x. Now, if this is to the power of 8, we're going to have a scenario where we've got 8 of these brackets. And you can hopefully see that logically the only way of producing a term without x's in it, how many have we got there? 2, 4, 6. I need 2 more. The only way of doing that is if you have 3 times 3 times 3 times 3, etc. That's very messy, right? Or 3 to the power of 8. So that's what we've just done there. Okay. Let's see if we can delete that quickly. Okay, brilliant. So that's where we're at with this. That's our first term. What's going to happen in our second term is now we've got 8, choose 1. So out of those 8 brackets, we're choosing one of the x's. Now, and then that means we're going to have, for that to happen, 3 to the power of 7, x to the power of 1. And then next, we're going to, the third term will be 8, choose 2. This is our x squared term, so we're going to have x squared. Now for an x squared term, that means we're going to have a 3 to the power of 6. So you can see that our first term, our first number, 3, is going, its powers are going down each time. It starts off at the highest power, 8, and drops to 7, drops to 6. And now, in the next one, when we go 8, choose 3, it will be 3 to the power of 5. Now, this is our x cubed term. We've got 8 chances, or 8 options of choosing an x from, and we're choosing 3 of them. This gives us our x cubed term. Now we've got our first 4 terms. We're going to simplify. 8 choose 0. You can do this on your calculator, but anything choose 0 is 1. So it's going to be 1 times 3 to the power of 8, which I do not know. 3 to the power of 8 is 6,561. 6,561 times x to the 0, which is just 1. Now, the next one. 8 choose 1. Well, that's going to be 8. But then we need to do 3 to the power of 7. So, again, not something I know. So 3 to the 7, 2187. So we have 2187. 8 choose 1 is 8, so I need to times 2187 by 8. And I get 17,496. 17,496 x's. My next term is 8 choose 2. So I type in my calculator 8, choose 2, and I get 28. And that's going to be 28, and I'm multiplying that by 3 to the power of 6 times 3 to the power of 6. And that gives me 20,412. And this is an x squared term. Then the next one is 8 choose 3. How many ways of doing that are there? Our calculator tells us there's 56. ways. 8 choose 3 is 56. I multiply that by 3 to the power of 5, and that gives me 13,608x cubed. Let's now move on to our second question. I've chosen question 3. It says find the coefficient, that's a number in front of the term x cubed, in this expansion. Okay, now just to help us understand how these work, you'll eventually be able to just do it without writing it out like this. But let's just start off by writing the first few terms. 7, choose 0. We're doing 7 this time because there are 7 brackets, right? 7 choose 0. 1 to the power of, times 1 to the power of 7. And our x term will be minus 6x, and that's all to the power of 0. And you can see our next term will be 7 choose 1. 1 to the power of 6 minus 6x to the power of 1. Our next term will be 7 choose 2. 1 to the power of 5 minus 6x to the power of 2. And the next term is going to be the one we want. 7 choose 3 into 1 to the power of 4 and minus 6x to the power of 3. So this is all we need. So we'll clear a bit of space here. Well, what is that? On your calculator, you're going to type 7 choose 3. Now 7 choose 3 is 35. So this will be equal to 35 times, now 1 to the power of 4 is just 1, but the next one, bracket minus 6, and I'm going to cube that. Minus 6 cubed gives me negative 216, so negative 216 times 35 gives me equals a negative 7560. So that means that our answer is going to be negative 7560x cubed, but they just want the coefficient, so I would report my answer as minus 7,560. Moving on to question 10. We have to expand 1 minus 2x all over 3, 1 minus 2x over 3 to the power of 12, and we're only going as far as the x squared term. We start off with 12. 12, choose 0. 1 to the power of 12 minus 2x over 3 to the power of 0. Next term, 12, choose 1, because we want we want an x, so that means we need 1 to the power of 11 and minus 2x over 3 to the power of 1. Our final term that we require is 12, choose 2, because we've got 12 x's, 12 brackets with x in them. To get an x squared term, we need to have 2 of them chosen and multiplied. Okay, so 12 choose 2, 1 is going to be to the power of 10, and therefore minus 2x over 3 to the power of 2. 12 choose 0 is 1, so our first answer is, the first term is 1. 1 to the 12 is 1. Anything to the power of 0 is 1. Next one, 12 choose 1, which is 12. We multiply that by 1 to the power of 11, which is 1. So we've got 12 times minus 2 over 3. That's negative 24 over 3, which is negative 8, so it's negative 8x. Then the final term that we're doing is 12 choose 2. 12 choose 2 is 66, and we're multiplying that by 1 to the 10, which is 1. So 66 times negative 2 over 3, so this last one, I'll do this in steps. It should be 66 multiplied by negative 2 thirds squared x squared. So what do we get for that? We get 66 times 4 ninths, which is 88 over 3. So our last term is going to be 88 over 3 x squared. Write that in here. 88 over 3 x squared. And that's how we do that one. The final question that I've chosen is one that comes up fairly frequently. It says, find the term independent of x in the expansion of x squared plus 1 over x squared to the power of 6. Independent of x means there are going to be the term that has no x, or x is to the power of 0. So normally that's our first term when we've had something like 1 plus x or something like that. But in this case, look, we've got x squared here, and over here we've got 1 over x squared. So let's eventually, again, I can see this straight now, I know what I need, but I want to show you by doing it the long way. 6 choose 0 will be our first term, and then our x squareds will be to the power of, x squareds will be to the power of 6, and our 1 over x squared will be to the power of 0. So it's clearly not that term, because you can see this one here is x to the 12, and that is just, we're multiplying that by 1, so that's not what we want. Let's look at our next term. 6 choose 1 x squared, and this time it's going to be to the power of 5, and we're going to have, maybe we can write x to the minus 2, because you know that x to the minus 2 is the same as 1 over x squared. This might make life easier for us, and that's to the power of 1. So you've got here x to the power of 10 multiplied by x to the negative 2, and that will give us x to the 8, which is not what we want, but we're getting closer. You might see the pattern. 6 choose 2 x squared, and that'll be to the power of 4, and our x to the minus 2 will be to the power of 2. Now let's look at this. We've got x to the power of 8, 2 times 4, and we're multiplying that by x to the negative 4. This term will give us an x to the minus 4. Look at that. This is looking positive. You see how we've gone down 4 each time. Sorry, that's x to the positive 4. So I reckon our next term is the one we want. 6 choose 3 x squared, and we're doing that to the power of 3. And we've got our x to the minus 2, and that's to the power of 3 also. This gives us x to the power of 6, and this gives us x to the power of minus 6. When you add those indexes, you get x to the 0. So this is going to give us our term independent of x. If this is a bit fuzzy, don't worry, we're going to have plenty of time to go over it. So the last step is to work out what that term is. So 6 choose 3, 6 choose 3. There are 20 ways of doing that, so that's going to be 20. And that is our answer, because the x's will cancel out to x to the power of 0, which is 1. So 20 is the term independent of x in that expansion. Well, I hope this gives you a bit of a starter. I'm sure you're going to have a few issues with this exercise, so don't hesitate to contact me if you are. Alright, God bless, guys.